Hi, everyone, and welcome to your lecture on Infancy and Childhood, Part 1. Our first stop in development is going to be with looking at the brain. It is important to remember that everything that we do, whether it's physical or psychological, always starts out in the biological, that being the developing brain. As a child is born, it's important to understand that they're going to be born with more neural connections possible than what they're ever going to utilize, peaking at around 28 billion at 7 months in utero. So please understand that this first line says that it is before they are born, they have roughly 28 billion possible connections. These neurons are going to get pruned down to about 23 billion at birth, meaning that you're really going to see that it's a use it or lose it kind of rationality for the brain. The neurons that get used, they're going to maintain, and everything else will get pruned away. The reason for all of these neurons is to allow for the greatest mental flexibility possible. In other words, the brain is able to make lots of connections. It's waiting for the environment to let the brain know what connections need to be maintained. Here you see it in a more visual form. Think of this as these are the exact same starting neurons, but this is the branching that you see after 3 months and after 15 months. It's not that you've had new neurons really added to the equation. It's just that there are more dendrites, more points where the axons and the dendrites can speak. In other words, it's the difference between back roads and major highway systems. The brain is trying to make connections so information can travel as quickly as possible. When we talk about development, everything unfolds based off of your genetic instructions. These genetic instructions occur in sequence. So as the brain unfolds based off these genetic instructions, bodily functions will occur also in sequence. This means that a child will stand before they walk, they'll babble before they talk, and this is what we talk about as maturation, a growth process that enables orderly changes in behavior, relatively uninfluenced by experience. Often people will say they learned to walk, but the reality is you matured into that behavior. As a bipedal species, we're all going to stand and walk. We are just waiting for our brain to allow us to have the neural connections to instruct our muscles to do that behavior. The first thing that we look at is the difference between motor skills present. They go into really two large categories, gross motor coordination and fine motor coordination. It's important to note that children will have gross motor skills first before they develop fine motor skills. An example of a gross motor skill would be using your large muscle groups, a child being able to stand or maybe taking steps, as opposed to a child being able to coordinate a left-right walking of up and down the stairs. A child might be able to grasp a toy with their full hand when maybe only their fingertips are absolutely needed. So the use of fingertips would be considered a fine motor skill, while grasping with the entire hand would be a gross motor skill. Again, as we talk about gross motor coordination, there are two other ways that we can look at this. A cephalocaudal trend, which means head to foot, or a proximal distal trend, meaning center towards the extremities. In a cephalocaudal trend, it would make sense for a baby to raise their head before they can walk, or bring their hand to their mouth before they kick a ball. In a proximodistal trend, the idea is that the center of the body is going to develop before motor coordination to the outward extremities. In other words, sitting upright before having hand manipulations would make sense. The brain development in humans is obviously immature at birth, and the neural networks are growing increasingly more complex. Because of this growth in neural connections, it can actually explain why we seldom have memories that predate our third birthday. It's not that a child is incapable of forming a memory, it's just that the neural connections needed to maintain a memory might not be there or might get pruned away. In infant memory studies, they were able to show that infants do maintain memories for a short period of time. And another reason that we might fail to have memories of our very early childhood would be because at around the age of 5, our brain starts to compartmentalize and organize information differently. It might have been there, it's just no longer accessible. An interesting study on babies' memories was done by Rovey and Collier. They looked at 3-month-old babies and taught them that if they were to kick their foot, they can make a mobile, dance, and they found it really enjoyable. After learning this behavior, the babies were able to maintain this learning for about a month. It indicates that babies, in fact, can remember things over a certain duration of time, but the memories weren't permanent. As we continue to talk about motor development, it's important to note that the order in which we learn these things all happen based off our genetic information, but it's timing that can be influenced by our environment. If we look at a nurture approach, Ugandan babies usually walk by about 10 months, or here in America, our children usually walk around 12 months. The difference is that many Ugandan babies are very rarely ever put down. Since they are constantly being held by their mothers, they get the rhythmic physical contact that is helping stimulate their brain for walking. In America, we put our babies in strollers or in toys that allow them to kind of bounce, and that doesn't give them the same sensation, therefore, it doesn't stimulate their brain. If we look at it from a nature perspective, identical twins typically begin sitting up and walking almost on the exact same day. There is some interplay between nature and nurture. With biological maturation, when we look at this, it is also the maturity of the cerebellum that allows our ability to walk. So you can't walk before your brain is able to take on that ability. Remember, your cerebellum helps with procedural memories and smooth motor coordination, which is necessary for us to walk. Before about the age of 1, your brain may not be mature enough. So just understand that you can't force a child to progress faster than their biological readiness would allow them to be. When we look at developmental norms, they're often used by doctors, psychologists, and educational specialists as ways to determine where a child is in comparison to others. In other words, they're used as benchmarks. And there's always an allotment for a certain amount of variation. Here we have a very general chart that would indicate progression of motor skills. The red line shows that at this point, 50% of children should have acquired this skill. Now, it is important to note that if your child is in the 25th kind of percent of babies that have acquired that skill, it doesn't mean they're going to be Olympian. And if they achieve it a little bit later, it doesn't mean that that's necessarily a bad thing or an indication of a problem. Notice if you get to standing while holding on, there's a lot of variation towards like the later end. What we are concerned is that children get it. Now, if your child is at the 90th percent at that time, your doctor might raise a concern, but there's a lot of room for variation. We're now going to get into Piaget's theory. So Jean Piaget was a Swiss cognitive developmental psychologist, and his entire theory was that a child's mind develops through stages. So he is a stage theorist. He felt that a child's mind was not a miniature model of an adult mind, and in fact, that children were active thinkers. They were constantly trying to construct a more advanced understanding of their world. This means that the younger the child, the more simplistic the construction. But as they get older, they add more information to their schemas and build much more complex cognitive ways of looking at the world. He used the idea of schemas, a concept or framework that organizes and interprets information, as the core of his theory. And again, we go back to assimilation and accommodation, the two ways that we adjust our schemas. We assimilate information into a schema to add more detail, or we accommodate a schema when we need to make a new framework to understand new information that deviates from an existing schema. Here's Gabriella. She's learning her schema for cow from a picture book. Next, she's going to try to apply this to the real world. So she sees a moose and calls it a cow. She's trying to assimilate. But since she has her mom there, her mom tells her it's a moose. Gabriella is going to then change her schema for very specific information for cow, and she is going to create a new schema for moose. And she'll add in the information that she continues to learn about moose into that schema. Piaget's theory is not exhaustive of all aspects of development. In fact, he primarily looked at cognition, all the mental activities associated with thinking, knowing, and remembering. He has a 4-stage theory and said that children experience spurts of change and then stability. So really kind of think of it as stairs. there's this huge upward change, and then they plateau for a bit before they can have another huge upward change. This isn't agreed upon by all theorists. These are the 4 stages that we're going to look at: sensory motor, pre-operational, concrete operational, and formal operational. In the sensory motor stage, babies take in the world by using their senses and their ability to move, hence the name sensory motor. The sensory motor stage goes from birth to about 2 years of age. Children younger than 6 months of age don't have a specific ability called object permanence. There's a video that will be attached in Schoology that will give you a good example of object permanence. Simply put, a child younger than about 8 months of age is unable to recognize that when something is no longer visible, that it still exists. In other words, they don't have this cognitive ability to understand that objects are permanent. By about 8 months of age, a child should gain object permanence. And if you were to do something like you see in this little scenario below, hide a stuffed toy under a blanket, the child should then actively look under the blanket for the toy. Things are no longer out of sight, out of mind. It is important to note that this stage continues on until the age of 2, so it doesn't end with object permanence. Piaget looked at other ways that children think. He had something called primary, secondary, and tertiary circular reactions. This is just to prove to you as you go down to C, the tertiary circular reaction, that this is still in the sensory motor stage, but it goes from 12 to 18 months. So what you guys need to be concerned about is the idea of object permanence, but there is additional cognitive development that happens in the first 2 years. We're just not going to get that deep into it. Later thinking and learning do appear in the second year. Children will start to have mental representations. They can form mental images of objects and events and begin to use them in thinking and problem solving. In other words, children can construct ideas. Their schemas are starting to develop. Piaget believed that children in the sensory motor stage could not think, or that they didn't actually have what he called abstract concepts. However, recent research shows that children in the sensory motor stage can think and count. Maybe not in the way that we would feel comfortable with, but they can show a basic understanding of universal principles. Children understand the basic laws of physics, and we know this by how long they stare or are amazed at something that is improbable. So imagine throwing a ball in the air and the ball stops in midair or disappears. For a child, they understand after 2 years of dropping things from high chairs that what goes up must come down. When it stops in midair or disappears, they stare at it for a very long time trying to puzzle out why it's violating a natural law. Another criticism comes from a Wynn study in 2000. He said that children can count, but again, like I said, maybe not in a way that we feel comfortable with. So in this really simple experiment, he would show a child in the sensory motor stage these cute little Mickey Mouse type characters. A screen would come up, an empty hand would enter, and they would remove only one object. Now, again, you have to remember that by about 18 months to 2 years of age, children have had objects in front of them taken away. They've had multiples and then maybe eaten all their Cheerios down to 1 or 2. They understand that you take something away, there should be fewer than what were there. And they might not be counting in 1 and 2, but they do kind of get the general understanding. So when the screen drops down and there's only one Mickey Mouse there, the child doesn't really look at it too deeply. However, if the screen comes down and there are 2 Mickey Mouse, which is improbable, well, the child sits there and goes, there's something wrong here. And they will again make an indication or stare at that possibility for a much longer time. The next stage we talk about is the pre-operational stage. And this occurs from 2 to about 6 or 7 years of age. A child that is pre-operational is too young to perform what he called mental operations. And the most famous of this is going to be the beaker experiment. In the pre-operational stage, children gradually improve their use of mental images. Piaget used the term conservation for the awareness of physical quantities that remain constant in spite of changes in their shape or their appearance. He said that pre-operational children are unable to solve conservation problems. In the next video I'll have post to Schoology, it will run you through a good example of conservation. But just to give you a quick talk through about his beaker or his flask experiment. Children would be shown, number one, 2 cups that have the exact same amount of liquid, and they would be asked, is there more in glass 1, more in glass 2, or are they the same? And once the children agrees that the water present or the fluid present in both glasses is the same, the researcher would then go into step 2. They would pour the glass from one of the cups into a tall, narrow cup, and you would end up with the third scenario. Now, every one of you should be able to unpour that cup, that narrow cup, back into the wide cup and realize it's still the same amount of water. But for a pre-operational child, they can't maintain or conserve the volume, and so they immediately go that the object on the right must have more because it's taller. I will link this video into Schoology so you can see an example. These are all variations of conservation. They deal with number, matter, length, volume, and area. This is another cartoon that if we had time, we would talk about. Cut it into a lot of slices, Mom. I'm really hungry. In this comic, essentially the child thinks that the more cuts you make increases the amount of pizza that is there. Why does all of this happen? Well, here's the inability that these children have. First off, they have what we call centration. They can really only focus on one feature of a problem at a time. So in the pizza, it's either the number of slices or the size of the pizza, but not both. In the flask or the cup situation, it's either the width or the height, not both. They lack irreversibility. So they can't reverse what had happened. They can literally only envision the situation that is in front of them. With us, we can uncut the pizza, we can unpour the cup. And these children are often what we call egocentric. So they experience egocentrism. Their thinking is limited by their viewpoint. Part of this would be something called animism, the belief that all things are living. A child at this age might get upset because you sat on their teddy bear and he couldn't breathe, or that you knocked their bike over and it got a scratch, so now it's hurt and has a boo-boo. These children aren't trying to be self-centered. That's not what we mean by egocentrism. It's just that they only really seem to understand the world through their own lens. They don't have enough experience to really kind of empathize or see it from someone else's vantage point. I will link this video also into Schoology. This is the egocentrism test, often called the mountain experiment. It's important to note when looking at this, a young child only sees things from their perspective. So when looking at the mountains, the child will say what they saw, but they'll assume that the person on the other side of the table, who might have their vision blocked, sees what they see, not the opposite of what the child sees. I know this is a weird way of explaining it, but if the child sees a bear and a snake and their bear and snake is blocked by a mountain for the person sitting across from them, they will still say the person sitting across from them can see the bear and the snake because they assume what they see is what others see. Another variation of something like this that expresses the egocentrism in a child would be asking a young child, why does the sun come up? And their response might be, because I need to wake up. Basically, the child understands the sun rises because it's time for them to get up in the morning, which is a very egocentric way of thinking. A criticism of Piaget's pre-operational stage comes from Deluc in '87, and he said that children are able to use some mental operations. One example would be giving a young child a diorama where they hide a dog behind a couch. A 2.5-year-old couldn't locate the stuffed dog when used in an actual room, but a 3-year-old could transfer the knowledge from the model to the actual room and find the stuffed animal. This also brings up a concept called theory of mind. Theory of mind is your ability to understand how someone else thinks, to walk in their shoes, to think like they would, to understand their mental state. And this is a perfectly good example that we often use to test or probe a child's theory of mind. You have Sally and Anne. Sally puts her ball in a red cupboard. Sally goes away. Anne moves the ball to a blue cupboard. Sally comes back. Where should Sally look for her ball? We all know that Sally was absent, and so if we were to think like Sally, we would say she would look in the red cupboard. A child who lacks theory of mind would sit there and say they should look in the blue cupboard because they know where the ball is. Theory of mind is often a deficit of children who have autism. Now, autism is a spectrum disorder, and it can be marked by many other aspects: sensitivity to touch, impaired communication. But often, what children who are autistic have, and especially, again, we're talking about a spectrum, is they have a difficulty understanding other people's states of mind. So, a child with autism wouldn't have answered the way we might answer for Sally. Another way of looking at theory of mind is children who are deaf who have hearing parents. If their parents are not fluent in sign language, because they have different communication systems, they may have a very hard time understanding each other. They have minimal opportunities for communication, and therefore, understanding what's going on in another person's mind is hard for a deaf child to learn. The next theorist that you guys need to know is Lev Vygotsky. He was a Russian psychologist that was asked by the Russian government to come up with a cognitive theory to rival Piaget. While I say that, please don't understand that because he was asked by his government to come up with this theory, his theory is wrong. In fact, his theory is used a lot in modern education. Vygotsky felt that children became more capable of thinking when they had more access to language. So for him, this is really kind of more around the age of 7, when children are fully capable of using their native language. They no longer have to think aloud. They can start to internalize their language and rely on their own inner speech. And he said, what we're looking at for children at this age is what we call the zone of proximal development. The gap between what a learner can accomplish alone or what he or she can achieve with guidance from a more skilled partner. The more skilled partner in this case would be something like a parent, a teacher, a coach. Visually, this is the best way to explain the zone of proximal development. There are a couple of different zones. There's the zone of I can do it all by myself. This is someone who is past the zone of proximal development. There's no way, I don't have the base skills to do it. So they're not even close to the zone of proximal development. But the zone of proximal development is, I can't exactly do it. I have the building blocks, but I need a little bit of help to get there. And when they're in that area, this is when their society and the people around them help them with their learning. Scaffolding is a method that fits into the zone of proximal development, where the more learned person, the teacher, the coach, the older sibling, whoever it might be, is able to take the material and break it into smaller, meaningful chunks, allowing the child to learn it in pieces instead of as a complete and total whole. This might be when a teacher introduces the idea of the sound of a letter before putting the letters together and practicing the sound with that, and then getting the kids to recognize the entire word. Again, the idea is that any information should be able to be broken down into more easily digestible chunks of information. Piaget and Vygotsky definitely approach cognitive development in very different ways. With Piaget, he felt that children's exploration is what let them know more about the world, while Vygotsky said that it really was interaction with other people in their society, people who could provide guidance and also scaffold. Piaget thought that cognitive development was basically a universal process that everyone experienced, and Vygotsky felt that where you come from and the culture that you live in had a really big impact on the development of your cognitive self. And again, you have this issue of language. Piaget said that the gradual mastery of language is just another aspect of cognitive development, where Vygotsky felt that you actually had to know language for your thinking to develop. The third stage that we have is concrete operational. During this stage, everything that the child couldn't previously master in the pre-operational stage, they've now mastered. They have reversibility, meaning that they can actually undo problems, kind of in the beaker experiment, pour this skinny, tall glass into the wide original glass and see that it hadn't changed. Decentration, they're able to actually take on more than one feature of a problem simultaneously. So you can start introducing things that have multiple moving parts. And they become less egocentric, and this happens with the gradual mastery of conservation. An example of a child that is in the concrete operational space would be something like this. They still don't really fully grasp abstract concepts. They need to be walked through them a bit more. So imagine coaching a soccer team and telling them you want them to move to space. For a younger child, this might evoke in their mind literally outer space, and the question of how to move there becomes impossible. But the coach or the teacher might have to explain to them, we're going to use the term space to mean an empty area where you can't touch any of your partners. They might not immediately get this conceptualization. The last stage we have is formal operational stage. This Piaget felt happened around the age of 12, and this is when we start to develop full cognitive abilities. Now, he did not think a 12-year-old was going to be as intelligent as an adult, but that they could start to take on hypotheticals and abstracts. An example of something like formal operational thought would be adolescents that are able to solve something like an algebraic equation. They can see the letter A as a variable, not just a letter. They can become idealistic. They can see the world in all its possibilities, but also an ideal world, one that would be their version of perfection. And they can become more logical. So they can start thinking in hypothetical ways and use more deductive logic and reasoning. Some of the critiques of Piaget were that maybe these could possibly occur earlier, that the formal operational stage might actually be seen in maybe children as young as 7. An example of this would be asking a child, if John is in school, Mary is in school. John is in school. What can you say about Mary? And if the child answers that Mary is in school, they're using a form of logic.